Welcome, and thank you for joining us for the Eco-Visualization as STEAM Visualizing Local Water Quality Data presentation. We want to thank everyone who contributed to making this conference available and want to remind everyone that we all share a responsibility for caring for watersheds where we live and visit. If you're using the alt text for images and you would like more details about about an image, please contact Dr. Amanda Galbraith at agalbra6@utk.edu. We are using this space that we are sharing in a way that is accessible to you. And I would like to go ahead and introduce myself. I'm Joy Bertling. I'm an assistant professor of art education at the University of Tennessee. And I'm also a director and principal investigator on the data visualization project, which is housed at the University of Tennessee. And now I'm going to let the other project team members introduce themselves.
I'm Amanda Galbraith, and I serve as the postdoctoral research associate for the Data Visualization Project at the University of Tennessee, Knoxville. During my 18 years as a visual art teacher in K-5 schools, the student artists with whom I worked created visual stories based on their experiences, investigations, and possibilities. Data visualization is valuable for student artists because it challenges them to make connections between several content areas, civic engagement, and their art making.
Hi, my name is Tabitha Wandell. I am a graduate research assistant on the Data Visualization Project, and I have especially enjoyed working on this project because I feel like it has given students choice. It links math, science, and art together, and it promotes relevance in classroom learning.
Hi all, my name is Rita Swartzentruber and I serve as a graduate research assistant on this project. One of the things that I love most about data visualizations is that it gives students the chance to put their own voice into creating something, especially in mathematics.
During the session, we will explore professional eco-visualizations and share eco-visualizations created by student artists. We will discuss the challenges we experienced in implementing a data visualization learning segment at the middle school level and the interventions we created to address the challenges. Additionally, we will consider ways community partners can contribute to a data visualization learning segment and explore potential classroom applications for data visualization. In comparison to traditional graphs, which also visualize important information, or can, arts-based data visualizations invite viewers to process the information through more emotive or sensory connections, or imagery, oftentimes. But both of these images convey data about how much carbon dioxide trees in a specific location absorb over time. The image on the left breaks down the absorbed carbon dioxide above and below ground by different types of trees. The image on the right visualizes the carbon dioxide absorbed over time by the entire forest using the scale of the sphere and the undulating patterns on the surface to communicate the data. The term eco-visualization has been used to describe artworks that reinterpret environmental data to promote stewardship, or arts-based data visualizations that inspire appreciation for natural phenomena, and visualizations that raise awareness of environmental threats. Through eco-visualization, artists, designers, scientists, and concerned citizens aim to unsettle anthropocentric modes of being in the world, to make ecological relationships visible, and to embolden sustainable acts. This eco-visualization by artist Jenny Kindler visualizes 100 U.S. bird species that are threatened or endangered by climate change. Within 50 years, these birds may be extinct. When Kindler was commissioned to install a second version of this work at a specific site, she again represented bird species, but changed the sample to represent birds indigenous to the installation site. This work has also been reimagined as a digital collage that allows viewers to hover over an image of each eye to see Audubon illustrations and observations about that bird. So in looking at this work and reading about it online, I'm unsure if the size of the bird eye corresponds to anything in the data in terms of whether it signifies the size of the bird, the number of these, if the size of the eye signifies the number of these birds left in the wild, or if it was just done for aesthetic concerns. So there are a lot of questions, but these are things that students can discuss and even evaluate what would have been most effective. This eco-visualization could be a good one for introducing elementary students, upper elementary students to data visualization, as it's fairly simple statistically and symbolically, much like artists like Chris Jordan's data visualizations. Because of our emphasis on statistical literacy in this learning segment, we focus primarily on visualizations of quantitative data, which is numerical data. For instance, this eco-visualization shown here represents the carbon emissions emitted by 20 different global nations, using a visual of varying numbers of balloons. The artist visualizes data through the size and placement of the balloons and the labels, which enable comparisons between countries. Each red-orange balloon on the structure represents 100 billion tons of carbon dioxide emitted in 2014. The balloons are grouped by nations, so nations with higher emissions are represented by a larger group of balloons. In this work, the symbol of the balloon can bring in a host of associations for viewers, which could include air, childhood, and so on. So I would encourage all of you to think about what associations do you have with balloons, and how do those associations influence the way that you might think about what you're seeing here with this data? How do they enrich your engagement with the data? As we mentioned in the title, we chose to focus on data about a locally relevant issue of water quality in streams and rivers. There are many approaches to exploring data about water, such as drinking water, stormwater runoff, rainfall amounts, water quality in streams, rivers, lakes, and ponds, fishing advisories, and water use and conservation, among others. We wondered what ecological issues might inspire your students to create data visualizations. In the session materials, we have provided a handout with space to generate ideas about these topics, as well as questions we will visit later in the session. Please pause the presentation at this point to individually generate ideas or talk with others if you're viewing in a group about identifying locally relevant matters that might inspire data visualizations. Please hold on to your ideas and we will revisit them later in the presentation.
Thank you for thinking about issues that are important within the communities in which you live and teach. We would now like to share what it looked like as we explored the topic of local water quality data with a group of 8th grade students in a STEM class. This is an image from the Tennessee Department of Environment and Conservation of all the bodies of water in Tennessee. This map shows us that several bodies of water within our state and our region of East Tennessee are designated as impaired. An impaired body of water is one that does not support all of its intended uses, which may include use as a source of drinking water, animal habitat, irrigation, and recreation. A body of water may be marked as impaired for reasons such as elevated chemical concentrations, siltation, or the presence of unsafe bacteria. Unfortunately, many of the bodies of water in our state and immediate geographic area are designated as impaired, which caused us to wonder, why are they designated as impaired? What might be causing the impairment? And what could be done to regain a supporting designation? We developed these essential questions to guide the work students would do during their investigation of water quality in East Tennessee. Through the enduring understanding, we sought to position data visualization as a tool for finding and telling stories about water quality to inspire community change. Testing all of the bodies of water in our area would have been too overwhelming and would have taken more time than we had for this project. Therefore, we selected 4 streams and rivers as our focus sites. We used historic and current data from the Tennessee Department of Environment and Conservation for the 4 local sites we selected and gave the students an opportunity to test collected samples from the same sites to create their own observations. We would like to encourage you to be willing to take on projects like this, even if you aren't experts yet in the subjects that are important to your students and community. We want to mention that we did not come into this project with a background in water ecology, but we were able to research enough to know what we needed to provide the students for learning in this project. When designing a data visualization learning opportunity, it is important to consider what aspects of the project you can help with so students can focus their time on the learning objectives. For example, we built in supports early in the project, such as collecting the water samples for the students and selecting water testing kits that would measure factors that connected the historic data to the data the students would be collecting. These actions allowed for students to have more time to analyze their data and create their visualizations. After the students collected and organized their data and conducted a little more research about water quality, they began to think about how to visualize their data using various artistic approaches and materials. We will look at the completed projects first, then discuss some of the challenges that arose during the project, as well as the interventions we developed to address them. These students chose to represent the different types of microplastics that were found to be present in the Tennessee River. The data came from the work of a scientist who swam the 652-mile length of the river, collecting data along the way, and discovered that it was one of the most polluted rivers in the world compared with others that have been documented. In the visualization created by this team of students, each of the colors represent the percentage of the source of plastic that was found in the river, such as yellow representing the amount of polyethylene and the braided pink representing fabric. By educating viewers about the types of plastic pollutants, viewers can begin to understand the products and industries most responsible for polluting our beloved Tennessee River. This group dug very deeply into the research process. Every question they asked directed them to new questions. What began as an investigation of nitrates in local water sources morphed into research about states with higher concentrations of nitrates in the groundwater, to fruits grown in those states, and finally to using color and size to represent the naturally occurring level of nitrates in the fruit from each state, along with the added and unhealthy levels of nitrates absorbed into the fruit from polluted groundwater, shown here as colored spots on the fruit. These students wanted to represent the data from fish consumption advisories in local rivers due to elevated levels of metals. They decided to specifically focus on mercury. They chose to use a representation of a native fish, the symbol of a mercury thermometer to represent the mercury readings in the water, and the imagery of a healthy environment with a storm approaching, a doctor's office, and a graveyard to show the changes in fish health and potential impacts on human health if consumed. The name on the tombstone, Easton, is a phonetic play on East NAEA23, a name used commonly to refer to our area. This group was interested in sources of E. coli in groundwater and the trend between good habitat scores and low E. coli versus high E. coli readings and poor habitat scores. They tried to connect the pop culture meme that ice cream machines are always broken at a certain fast food establishment with acceptable levels of E. coli and unacceptable levels of E. coli with the representation of a toilet. They showed their connection between habitat scores and E. coli on rolls of toilet paper. We really appreciated their attempt at divergent thinking and all the fun they had while they created the visualization, while recognizing that the connection to the data becomes a little confusing at times. These students worked to take on this ambitious task, and their work is a good example of how difficult it can be initially for students to visually represent numbers.
As we mentioned earlier, there were some challenges during the project that required some instructional approaches. These included conceptualizing forms of data, combing through the data, combining what they learned from the new and existing data, and creating a plan to keep the data in the visualization. Early in the project, we noticed the students seemed to be having trouble translating the numbers from the historic data and the data they gathered into a visual presentation with meaning. This graphic was helpful in explaining how working with the data is a process and that there is a difference between a visual presentation and a visual presentation with the element of a story. In several cases, we, the research team, organized and refined the data from the original sources to make it more accessible for students as they interacted with it. We also saw that students needed some support in asking questions of the data. Therefore, we found it helpful to provide the students tools for sorting the data, such as prompts and suggesting mathematical processes they might apply. For example, for this group, we asked them to visually identify readings that fell outside of the acceptable range in 2 qualities of water, and then asked them to look for patterns between the observations they made about the readings. As we started the process of brainstorming about what their data might look like in a visualization, most of the students presented very literal ideas. Then, as we talked more about symbolism, they drifted away from accurate representations of their data. Therefore, we ended up creating customized thinking organizers for each group with open-ended questions that related to their selected data sets to help the students define the what and the how of the story they wanted to tell about their data. When we approached it as a process of telling the what, the connection to the data, with the how, the symbolism, they grew into being able to use imagery that directly represented their data and were able to use symbols to create meaning.
As the students started using more visual imagery, we noticed that they were starting to stray from representing the data. They would create artworks using imagery related to the topic, but not necessarily reflecting specific aspects of the data. Basically, it was functioning more as a data-inspired art rather than a data visualization, as we defined it. To foster a closer connection to the data, we showed this image of a work that we thought we could have more explicit connections to data and pose some questions during a class discussion. This work depicts the problem of plastic in the world's 5 oceans. We opened with a discussion about what snow globes might represent and why people might have them. Then we asked the students about what information this image communicates. We asked the students to imagine there are differences in the bodies of water represented by each globe, and ask what might the artist have changed about this image to visually represent differences between the bodies of water. We also paired arts-based data visualizations with the data represented to give examples of how artists make decisions to communicate data. In this example, the artist had to figure out how to accurately represent the proportion of actual distances to the lengths of straws because it would be difficult to represent 5,400 miles the blackberries traveled with a straw that was actually 5,400 miles long. We organized the information into a table so that the students could see how using ratios can make it possible to display large quantities in an image. While the description of the image listed the lengths of all the straws in inches, and the image listed the miles traveled for each ingredient, there were some discrepancies in the ratio calculations. We would like to point out that it would have been more accurate to make the blueberry straw 2.92 inches long based on the ratio of straw length to distance depicted for the other ingredients. We showed this architectural visualization to students because the artist used a few different approaches to display large amounts of data. In this case, the colors and sizes of each column communicate a percentage of ecological data. The artist also included QR codes with links to the original data sets used to determine the percentages. To help students think about how they might translate data into their visualizations, we gave them the following example. If the key is 100 equals 10, and pollutant X is represented by symbol Y, there are 100 X's, then we would need 10 Y's. So for this example, a normal temperature would be 98.6, which would correspond to mercury readings of 0. The students then converted their observed mercury averages to readings on a thermometer using a range of temperature to represent degrees of the problem of mercury contamination in fish. For example, a reading of 99 represented a cause for alarm, while a reading of 107 represented a major problem.
Another way to connect students with community needs is to partner with community organizations. Community partners can add real-world context to how data can describe community needs and inform solutions. Reasons and methods for establishing community partnerships can vary depending on the needs of your community and the organizations available. For our project, we found it was helpful to start the process by creating a list of several organizations in the community that worked with different aspects of water quality. We then narrowed the list to community partners that aligned with our specific needs in the curriculum, then further narrowed the list to organizations who were able to work with the schedule of the class. It can shorten the process of establishing partnerships by starting with people you know, or working with organizations that have already been connected with the school. In our experience, the students were more engaged with community partners when they visited in person rather than through Zoom. However, we did note a slight dip in student self-reported engagement during both types of community partner visits. This could be the result of the contrast between the hands-on activities that occurred during the rest of the project and the more passive environment during the community partner visits. However, the community partners contributed valuable knowledge and personal experience that otherwise would not have been accessible. Therefore, we really value that unique perspective and consider the integration of community partners to be an area for continued exploration and refinement. Previously in the session, we generated ideas for local ecological issues that might inspire your students to create data visualizations. We would like to return to those now and expand on one of the issues you listed to envision what working with eco-visualizations might look like with your students. Please pause the video if you would like to take time to think about the prompts on the handout and document your ideas. Thank you for your interest today. We hope that you leave inspired to help your students create art based on environmental, ecological, and sustainability data. Data visualization helps students connect with data as they observe, interact with, and shape our world. If you are interested in more instructional resources, please use the QR code or visit the web address on the screen to connect with the Data Visualization Project community.